In a study of pulse rates of men, a simple random sample of 149 men results in a standard deviation of 10.9 beats per minute. The normal range of pulse rates of adults is typically given as 60 to 100 beats per minute. If the range rule of thumb is applied to that normal range, the result is a standard deviation of 10 beats per minute. Use the sample results with a 0.05 significance level to test the claim that the pulse rates of men have a standard deviation equal to 10 beats per minute. See the accompanying StatCrunch display for this test. What do the results indicate about the effectiveness of using the range rule of thumb with the normal range from 60 to 100 beats per minute for estimating the population standard deviation in this case? Assume that the simple random sample is selected from a normally distributed population. So if we click on the icon to view the display, here is our results. You can see that we're testing the variance in here, but what we want is the standard deviation. And then here are the results from that. Okay, so this is going to be brought into the notebook here. So the first thing we want to do is, let's take a look at the claim. So the claim is asking us, it says here, to use a 0.05 significance level to test the claim that the pulse rates of men have a standard deviation that is equal to 10 beats per minute. Okay, so what is the information that we need from the problem? Well, we know that the sample size is given to be 149. So we know that n is equal to 149. Okay, and then we're also given that the sample standard deviation of that sample size is 10.9. So we know that S is equal to 10.9. Okay, and then we also know that from the claim it's saying that the population standard deviation is equal to 10 beats per minute. So we know that the population standard deviation is equal to 10 beats per minute. Okay, now if you look in the display here, this is the variance. So remember that the standard deviation is equal to 10, and then the variance is squaring that 10, which is given 100. Now the reason why it's showing the variance is because we don't have a test for a standard deviation. So you would have to realize that taking the square root of 100 would give us 10. Okay, and then it gives us the sample variance, the degrees of freedom, the chi-square test statistic, and the p-value. So we're going to go ahead and then proceed. Okay, now what are the requirements? Well, the first requirement is that the sample is a simple random sample, and this requirement is satisfied since it is given that a simple random sample is selected. Number two, the second requirement is a fairly strict requirement that the population has a normal distribution. If this requirement is not satisfied, then an alternative method should be used to test the claim. Now, this requirement is satisfied since it is assumed that the population is normally distributed. Therefore, both requirements are satisfied and the primary method for testing a claim about a population standard deviation can be used. Okay, now let's state the claim and the opposite of the claim. Well, again, we saw that the claim is the population standard deviation is equal to 10. So we can say that the claim is the population standard deviation is equal to 10, and therefore the opposite of the claim would then be that the population standard deviation is not equal to 10. And so that's going to tell us what our null and our alternative hypothesis is. So remember that the null hypothesis always contains the equality sign. So therefore we know that the population standard deviation is going to equal 10, and then the alternative is going to be the opposite. So we know here's the equality, and we know the opposite of the claim is going to go in the alternative, and therefore we can see that the population standard deviation is not equal to 10. So let's go ahead and then put in our information here. So it says we're going to put in equals, and then the value of 10, and then we have not equals, and that's equal to 10, and let's check our result, and there's our answer. Okay, now it says identify the test statistic, but we're going to confirm that test statistic with our problem here. Before we move any further, we need to use the alternative hypothesis to determine whether there's a left, right, or two-tailed distribution. Since it's not equals, then we know this is a two-tailed test. Okay, now in step number 4, it says identify the significance level. Well, we're testing it at a 0.05 significance level, so therefore alpha is equal to 0.05. Okay, now we want to find the test statistic for testing a claim about the standard deviation or variance. And since we're dealing with the standard deviation, we know what we need to apply. Well, again, we know that n is the sample size, which is 149. We know the sample standard deviation is 10.9, and we know the population standard deviation is 10. So if we go ahead and put this into our formula, we take 149, subtract 1, times the sample standard deviation of 10.9 squared, all over the population standard deviation squared. Okay, so let's go ahead and do that, and we're going to round that to 2 decimal places. So we have 149 minus 1, which is 148, and then we're going to multiply that by 10.9 squared, which is the standard deviation. And then we're going to divide that by 10 squared, which is 100, and that gives us 175.84. 175.84. Let's check with our value up here. So we get 177.14. Now, if you look at our display, the reason why our number is just going to be slightly off is because they rounded the sample standard deviation. So what we're going to do is we're going to use the chi-squared test statistic that we get from the display, even though it's just slightly off from what our calculation is. And again, that happens because they're using all the particular values. So we're going to go ahead and put into 2 decimal places the one we get in the display, which is 177.15 for our test statistics. Let's go ahead and put that in here. So we get 177.15, and there is our answer. Now it says identify the p-value. Okay, so we're going to determine what the p-value is by using the test statistic that was given in the display. Okay, and then we're going to use StatCrunch to determine that. So in order for us to first write this out, we need to draw out the bell curve distribution. And since it's a chi-square distribution, we know it's going to be a right tail. Okay, and we know that from our alternative hypothesis that this represents a two-tailed distribution. And then we have chi-square value to be, or the test statistic of 177.15. Okay, now in addition to that, we need to know what the degrees of freedom are. Now recall that the degrees of freedom is n minus 1, and so that's going to be 149 minus 1, which is 148. Okay, and then we want to find that p-value. So in order to find that p-value, you want to find the probability of when that chi-square value is greater than or equal to 177.15. And then since it's two-tailed, we're going to have to multiply that by 2. So let's go ahead and open up StatCrunch. So we open up StatCrunch. Okay, what we want to do now is we want to be able to then go to the stat and then calculators, and then we're going to go to chi-square. Okay, we're going to put in the degrees of freedom, which is 148, and then we're going to say that this is going to be greater than, and then we're going to put in the test statistic of 177.15, and so therefore we're going to get this p-value here. Okay, now they're going to want us to round this to 3 decimal places, but before we do, we're going to take this entire value, which is the p-value, and then we're going to multiply that by 2. So I'm going to go ahead and copy this value, which is our p-value. Okay, and that's the p-value that represents one tail. Okay, and so we're going to take that p-value and then multiply it by 2. So let's go ahead and do that. So here we're going to take 2 and then multiply it by 0.05128799, and then we get 0.1025, and we're going to round that to 3 decimal places. So we get the p-value to be 0.103. Okay, let's check our display. When we come up here, we get a p-value pretty close to that, which is 0.0126, and then rounding that to 3 decimal places gives us 0.103. Oops, hit enter too fast. Let me put in 3 there, and there's our result. Okay, now we want to be able to state the conclusion. Okay, so in order to state the conclusion, we need to now compare this p-value with the significance level. So we know that the p-value is 0.103, and then we know the significance level is 0.05. Okay, if the p-value is less than or equal to significance level, we reject the null. If it's greater than the significance level, then we fail to reject the null. It's greater than, so we're going to fail to reject the null hypothesis. Okay, now we're going to state our conclusion. And so in order for us to state the conclusion, we're going to come back up here and look at the original claim. The original claim includes the equality. So the first 2 parts of the conclusion says it does not include equality, so we can cross out those. And since the original claim includes equality and we failed to reject the null, then we're also going to not use that, so we're going to use this one here. So that means we would say that there is not sufficient evidence to warrant rejection the claim that. So we're going to say fail to reject the null hypothesis, and again there is not sufficient evidence to warrant rejection. So we would say there is not sufficient evidence to warrant rejection of the claim that pulse rates of men have a standard deviation equal to 10 beats per minute. And so we would say the results indicate that there is not significant evidence that using the range rule of thumb with the normal range from 60 to 100 beats per minute for estimating a population standard deviation is not effective in this case. Check in our answer, and there is our result.